Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the southernmost moon. I'm Dr. Ed Krupp, director of Griffith Observatory, and this cheering and unusual astronomical event is part of a 24-25 campaign to follow the greatest monthly excursions of the moon. It is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. Griffith Observatory cameras are now targeting this view of the southeast horizon from below the observatory's South Promenade and East Terrace. In a short time from now, the moon will rise on this line just about as far to the south as we ever see it. The waxing gibbous moon, just a day and a half from full, will appear over that ridge about at 7:15 p.m. Pacific Daylight Time. The sun won't set in the northwest until 8:03 p.m. Pacific Daylight Time, and so it's still daylight here in Los Angeles. That makes it harder to catch the moon, but the Griffith Observatory live stream broadcast team is prepared to bring it to you. The broadcast team includes Patrick So, Observatory Theaters Manager, Matthew Burlando, Production Engineer, Vanessa Alarcon, Observatory Astronomical Observer, Digital Communications Coordinator Pixie Iwata, Camera Operator Jennifer Wong, and the two people I forgot to include. We first broadcast the southernmost moonrise, and I'm not sure which slide I'm on anymore. I couldn't, because I can't see. Okay. Southernmost moonrise last month on the evening of June 21st, and then in the early morning on June 22nd, we moved to the west side of the Griffith Observatory to the Major Standstill southern moonset line inscribed on the lower west terrace and broadcast from there the southernmost setting moon. And I am still confused because I'm seeing slides that don't look right. That looks like the one I was just talking about, so when I'm hitting, maybe I'm not getting them, because I should be, that's where I should be. The lighting is what's really tough, though. The moon hasn't risen and set. Nah. Yeah.
Can we move that closer to the screen? We could move this closer.
Yeah, I don't think so.
But this is the lighting.
I think this is a little better at the angle, at least. Okay. The moon hasn't risen and set this far south in more than 18 years. The moon is now tilted at the greatest angle outside the path of the sun. And on the ground, this means for the next year and a half, we'll see the most northern and southern moonrises and moonsets the moon ever reaches. This time is called the Major Lunar Standstill. Now, the greatest excursions of moonset are marked on Griffith Observatory's lower west terrace, along with the solstice and equinox sunsets and moonsets when the monthly excursion is least, at minor standstill. The most northern and southern moonsets last happened in 2006, when the observatory was still under construction for renovation and expansion. The stone for that line had not been placed in the pavement as it is now to the right of the gold line in this view. But this, in fact, is the Major Standstill northern moonset on January 28, 2006, before that stone was in place. Now, between now and around December 2025, the moon will, each month, rise and set as far to the north and as far to the south as it ever can, outside the sun's annual limits as shown on the diagram. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. The sun does something similar, but it does it over the course of a year. Every June, the sun rises and sets as far north as we ever see it, to the left in this diagram of the sunrise. And 6 months later, in December, it rises and sets at its southernmost limit, on the right-hand side. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and sunset seem to stand still, and the time when this happens is called a solstice, which means sun still. Well, if we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun and the moon and the planets and the stars all rise from somewhere on the eastern half of the horizon, on the near side of this globe, climb up the sky to their greatest height on that white arc called the meridian, and then head back down to the western half of the horizon. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around a spot directly above the North Pole of the Earth. If that is all that moved, the sky would be simple, but other objects like the sun, moon, and planets all move around the sky on their own paths at different rates. The sun's path is called the ecliptic, and it's just a reflection of the Earth's orbital motion around the sun. Sun takes about 365 days, a year really, to complete its circuit. And the sunrise migrates from north in June to south in December and back to north again in that time. Now the moon's a lot more complicated than the sun. Each month it travels from north to south and back again, and so the moon does in a month what the sun does in a year. But the moon on its path is traveling at a tilted position compared to the sun, and that means that the moon's monthly limits gradually change. We can see at the time of major standstill, the southern moon arcs very low across the sky, and then half a month later, far to the north, the moon rises and arcs across the sky again. That's in the major standstill that corresponds to the time that we have right now. But in fact, after the major standstill, 9.3 years later, the moon will do the same thing at its minimum limits. And so the whole thing is squeezed in, a little bit like an accordion, the limits of the moon's path pushed in toward the equator of the sky. And so we have the time of minor standstill also obvious in the moon's position. And then finally another 9.3 years later, and the moon's back to where we started again at its outermost limits. Not only in the south, but also, of course, once again, arcing high over the north. Well, the moonset lines on the lower west terrace of Griffith Observatory make this obvious. The northern, inner, and outer limits flank the summer solstice line that points to the northwest in this view. The gold line is the summer solstice line. The southern, inner, and outer limits flank the winter solstice line that points to the southwest. And again, the sun's line, the solstice line, is the gold one, and the two gray lines belong to the moon for the inner and outer standstill limits. Well, when the moon rises and the moon sets reach these limits, the limits don't seem to change much from month to month, and there are two periods when that happens, one at the moon's inner limits and another half cycle later at the moon's outer limits. These periods then, as already heard, are called the standstills, and each lasts about 2 years. The moon's limits still change through this period, but the change from month to month is small, just as the change of the sun's position at the solstices is small, and that's why they're called lunar standstills. So we're now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. And in another 9.3 years, the limits of the moonrises and moonsets will be inside the solstice points, as we see here, and will be at minor standstill. The monthly limits will then increase gradually, and in 2042, we'll have the next major standstill. So mark it on your calendar. Well, the moon behaves in this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun. Just a small angle, about 5 degrees, but that's enough to make a difference. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. And in this animation, we can see how the movement of the moon's orbit gradually changes the position of the moon compared to the position of the sun's path. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how that rotation of the moon's orbit changes the angle at which we see it. keeps on going all the way around, never ends, but after 18.6 years, it completes a full cycle. Seen from the side, you can actually see how the tilt works backwards and forwards in order to get the image of the, in order to get the position of the moonset and the moonrise changing. Although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon, track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61 year cycles to see and understand the full pattern. Well, despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins identified lunar standstill alignments in the station stones rectangle at Stonehenge, that rectangle that surrounds the innermost circle, constructed perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill southern moonrise and Major Standstill northern moonset. Here's the view of Major Standstill southern moonrise. It really isn't, that's just a fake for the moment. And here is the Stonehenge Station's view to the the Major Standstill northern moonset. Hawkins also proposed sight lines between certain gaps and pairs of archways formed by the large sarsen stones erected maybe 500 years later. This pair of openings here accommodates the Major Standstill northern moonset. Stonehenge, though, was not the first prehistoric monument assigned a major lunar standstill alignment. In 1908, British naval officer Boyle Somerville published a Major Standstill northern moonrise for the Callanish stones in Scotland's Outer Hebrides, seen here. And then in the 1980s, Gerald and Margaret Ponting instead favored an alignment to the low southern moon down the long avenue of the stones. And here that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric megalithic rings, and he identified Major Standstill southern alignments in the recumbent stone rings in northeast Scotland. This is the view to the southwest from the center of the Castle Fraser stone circle. The big recumbent stone operates like a stage across which the southern moon dances, and the alignment here, of course, points to the Major Standstill southern moonset. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old Major Standstill northern moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon Mounds at Newark, Ohio. You're looking at that axis now. And Stephen Patricia reconstructs here Newark's Major Standstill northern moonrise, looking at the moon rising in the north from the perspective of those monumental earthworks. An ancestral Pueblo great house, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the Major Standstill northern moonrise framed by distinctive rock pillars. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. And Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon here last October. Dr. Amanda Bosch of Lowell Observatory caught last December's full moon at Chimney Rock. Well, deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and throughout the rest of 2024 and most of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We're now about to go live with the Major Standstill southern moonrise from below the observatory's south promenade, along a moonrise line installed in the southeast loading zone and headed southeast over Elysian Park, Santiago Peak, and on to Palomar Mountain. The moon may be standing still, but Griffith Observatory never stops moving. By the powers invested in the City of Los Angeles Department of Recreation and Parks and Griffith Observatory, the observatory broadcast staff is going to elevate the moon above the southeast horizon in an event that happens only every 18.61 years. You are very lucky if you are here to see it. If you were here 18.61 years ago, you would have seen it, but you couldn't get in because the observatory was under construction. We have had to wait 18.6 years for this, and I know that your patience is limited. And so all I can ask you to do is take a deep breath and wait for the moon. It's not coming up today yet.